The lesson for today is derivatives of inverse functions. The AP standard for this says the chain rule and definition of an inverse function can be used to find the derivative of its inverse function provided the derivative exists. So the way that we're going to do this today is a bit of a hack. We are going to find the derivative of an inverse function at a given point without ever calculating the inverse function or the function of its derivative. So back in pre-cal, to find the inverse of a function, you first had to swap the x and y variables, and then you had to solve for y. For example, we could find the inverse of f of x equals x cubed by first replacing the f of x with a y. So we'd have y is equal to x cubed. We swap the variables, put an x where the y was, and then put y's where the x's were. Now we solve for y. If we take the cube root of both sides, the cube root will cancel with the cubed on the y, and we're left with the cube root of x is equal to y. Since what we've found is the inverse of our function f, replace the y with f inverse of x. Let's do an investigation of how answers of a function relate to the answers of the inverse function. Let's find the answers for f of x whenever x is equal to 1, 2, 3, and 4. F of 1 would just be 1 cubed. 1 cubed is equal to 1. F of 2 is 2 cubed. 2 cubed is equal to 8. And then f of 3 would be 27. F of 4 would be 64. A moment ago we said if you want to find the inverse of a function, that basically you're just swapping the domain and the range. In this table to the right, let's try that and see what happens. I'm going to take the range for my answers on the left, which are 1, 8, 27, and 64, and see what happens when I evaluate f inverse for these values. F inverse of 1 would be the cube root of 1. Cube root of 1 is equal to 1. F inverse of 8 would be the cube root of 8, which is 2. And then f inverse of 27 would be equal to 3. F inverse of 64 is equal to 4. Notice the domain and the range are indeed swapped. On the left here for f of 2, f of 2 is equal to 8. The f inverse of 8 is equal to 2. So the domain and the range have been swapped for f and f inverse. Now use what you've learned about inverse functions. If g of 2 is equal to 7, then what is g inverse of 7? So pause the video for a moment and think about that. G of 2 equals 7. 2 is the value from the domain. 7 is the value from the range. So that means that g inverse of 7 would just be the domain from g of 2 equals 7. So g inverse of 7 is equal to 2. You're just swapping the domain and the range. That leads us to rule number 1 for whenever we're trying to find the derivative of the inverse of a function at a point. If f of a is equal to b, then f inverse of b is equal to a. Now let's see what happens when we take the derivative. Starting from f of x equals x cubed, the derivative of f of x would be 3x squared. And we showed earlier that the inverse of f was the cube root of x. So to find the derivative of f inverse of x, let's first turn cube root into a rational exponent. That would be x to the 1/3 power. And so the derivative for this would be 1/3 x to the negative 2/3. And we can simplify that as 1 over 3 cube root of x squared. Take note of how I wrote f inverse prime of x. I put a parentheses around the f inverse. That way the inverse symbol doesn't get confused with the prime symbol. So we have f prime of x is equal to 3x squared, and f inverse prime of x is 1 over 3 times the cube root of x squared. For f prime of x, let's fill in those same values of x and evaluate. The ones we used before were 1, 2, 3, and 4. F prime of 1 is equal to 3 times 1 squared. That's just 3. F prime of 2 would be 3 times 2 squared. 3 times 4 is 12. F prime of 3 would be 3 times 3 squared. 3 squared is 9. 3 times 9 is 27. And f prime of 4 would be 3 times 4 squared. 4 squared is 16. 3 times 16 is 48. Let's look at the table we made before. For f prime, the values we plugged in for x were 1, 8, 27, and 64. If we plug 1 into f prime inverse, we'd have 1 divided by 3 times the cube root of 1 squared. So the cube root of 1 is 1. 1 squared is still 1. 3 times 1 is 3. Our answer for that would be 1 divided by 3. If we plug 8 into that formula, we'd have 1 over 3 times the cube root of 8 squared. Cube root of 8 is 2. 2 squared is 4. And then 3 times 4 is 12. So our answer for that would be 1 divided by 12. For 27, it'd be 1 over 3, cube root of 27 squared. The cube root of 27 is 3. 3 squared is 9. 3 times 9 is 27. So that answer would be 1 over 27. For 64, it'd be 1 over 3 times the cube root of 64 squared. Cube root of 64 is 4. 4 squared is 16. And 3 times 16 is 48. So the answer would be 1 over 48. Looking at the answers for the left column and the right column, do you notice any patterns? For this first row, f prime was equal to 3. And notice the denominator for f inverse prime is also 3. The answers for the right-hand column are the reciprocal of the answers from the left-hand column. So in general, the inverse's derivative at y is always going to be equal to 1 divided by the function's derivative at x. That leads us to our second rule for when you're trying to find the derivative of an inverse function at a point. That is that f inverse prime of f of x is just equal to 1 divided by f prime of x. Let's see how we can solve one of these problems. If you're given a function of x and you're looking for the derivative of the inverse of that function at some point, begin these problems by creating a table. The left-hand column is for f, and the right-hand column is for the inverse of f. For the first row, we use rule 1. That rule is dealing with the function itself and its inverse. For the second row, use rule 2. Rule 2 deals with the derivatives. Enter the given x value into the bottom right and top right parentheses of the table. For now, we'll just call this b. Step 2, enter that same value of b as the answer in the top left cell. We can do this because of rule number 1. That f and f inverse are just swapping domain and range. Step 3, set f of x equal to your given value b, and then solve for x. Your answer to this goes inside of the parentheses in the top left and on the bottom left. Step number 4, calculate the derivative of f at your point A, and let's call that answer C. C can go in as the answer in the bottom left cell and its reciprocal in the bottom right cell. This value of 1 over C is the answer that you're looking for. Now that you have the steps for finding the derivative of an inverse of a function at a given point, we'll see those steps in action in the next video.